solve this rational equation. So when trying to solve a rational equation, the first thing to do is multiply through by a common denominator of all the fractions in our equation. In this case, we only have two fractions, and their denominators cannot be factored any further, and so it's easy to see that the lowest common multiple of those two denominators is x plus 1 times x minus 2. So simply the product of the two denominators. So we're going to multiply through by this lowest common multiple or lowest common denominator. So we'll take 3x plus 3 over x minus 2 times x plus 1 times x minus 2 minus 4 over x plus 1 times x plus 1 times x minus 2. And that'll be equal to 3 times x plus 1 times x minus 2. So now this factor of x minus 2 can cancel with this factor of x minus 2. This x plus 1 can cancel with this x plus 1. On the left, we'll have 3x plus 3 times x plus 1 minus 4 times x minus 2 equals 3 times x plus 1 times x minus 2. So now we're going to expand these brackets. So on the left, we'll do some foiling. So we'll take 3x times x, which will give us 3x squared. Then we'll have 3x times 1, which will give us 3x. Then we'll have 3 times x, again giving us 3x. And 3 times 1, which will give us 3. This will be minus, or I guess negative 4 times x will give us negative 4x. Negative 4 times negative 2 will give us positive 8. And then I'm going to start by expanding the binomials on the right. So we'll have x times x, which will give us x squared. X times negative 2 minus 2x, 1 times x plus x, 1 times negative 2 minus 2. So on the left, we'll start combining some like terms. So we can combine 3x, 3x, and negative 4x to leave us with 2x. We'll have 3x squared plus 2x, and then we can combine 3 and 8 to give us 11. On the right, we'll continue to expand these brackets, so we'll distribute the 3 among the terms in brackets. So we'll have 3x squared minus 6x plus 3x minus 6. Then we can combine the negative 6x and positive 3x. So 3x squared plus 2x plus 11 equals 3x squared minus 3x minus 6. And now we're going to move all of our variables to one side of the equal sign. So let's move all of our x's to the left-hand side. So we'll subtract 3x squared and add 3x. Of course, we have to do the same over here. So that'll leave us with 0x squared on the left, 5x on the left plus 11 equal to negative 6. So then we'll move this constant term over to the right. So we'll have 5x equals negative 17. And then we'll divide both sides by 5 to get a possible solution of x equals negative 17 over 5. Now, to make sure that this is a solution, we're going to substitute this value in for x in our original equation. So we'll have 3 times negative 17 over 5 plus 3 over negative 17 over 5 minus 2 minus 4 over negative 17 over 5 plus 1 equals 3. So you may need to use your calculator for this. 3 times negative 17 will give us negative 51. So in that numerator we'll have negative 51 over 5 plus 3 over negative 17 over 5 minus 2, but we're going to put 2 over a denominator of 5. So right now it's over a denominator of 1, so we'll multiply numerator and denominator by 5 to make this subtraction a little easier. We'll have negative 17 over 5 minus 10 over 5, and we'll have minus 4 over negative 17 over 5 plus 1. Again, we'll put 1 over 5, so right now it's over 1. We'll multiply numerator and denominator by 5, so we'll have plus 5 over 5. That'll be equal to 3. You know what, while we're at it, we're also going to change this 3 to be over 5. So again, it was originally over 1. Multiplying numerator and denominator by 5 allows us to change it to 15 over 5. Now we can perform some simplification. So negative 51 over 5 plus 15 over 5 in the numerator is going to leave us with negative 36 over 5. So I'll have negative 36 over 5 over negative 17 minus 10 is negative 27 over 5. That'll be minus 4, which we're also going to put over 5, so we'll multiply numerator and denominator by 5 to leave us with 20 over 5. So negative 17 plus 5 is going to be negative 12. We'll have negative 12 over 5 here, and this will be equal to 3. Now, since in the numerator and denominator of both of these fractions on the left, we have more fractions with denominators of 5, we can divide both numerator and denominator by 1/5 in both of these fractions, which will get rid of those denominators of 5. So we'll have negative 36 over negative 27 minus 20 over negative 12 equals 3. Then we can reduce both of these fractions. So the one on the left can be reduced by a factor of 9. So if we divide 36 by 9, we'll have 4. Also, the negatives can cancel in division. Then if we divide 27 by 9, we'll have 3. So we have 4/3. Again, the negatives can cancel in division between the negative 20 and negative 12. So we'll have plus 20 over 12. And we can reduce this fraction by a factor of 4. So 20 divided by 4 leaves us with 5. 12 divided by 4 leaves us with 3. So we'll have 4/3 plus 5/3 equals 3. I'm going to continue this right here in this bubble since we're running out of space. So we have 4/3 plus 5/3 equals 3. Now let's determine if this is true. So 4 plus 5 is 9. So we'll have 9 over 3 equals 3, and that is definitely true. 9 over 3 is 3. So x equals negative 17 over 5 actually is a solution for this problem.